Hi guys, welcome to my YouTube channel, Field of Science. Myself Rohit. Today we are discussing about physics class 11 new chapter, Gravitation. You may expect 1 to 2 questions from this chapter. First we move on to Kepler's law. Kepler's law, there are 3 Kepler's laws. First Kepler law is all the planets revolve around the sun in elliptical orbital with sun as one of its foci. Here, all the planets around the sun are revolves around the sun with elliptical orbit like this in this path. As sun has one of its foci here, F1 means sun has one of its foci. The, the planet feels sun as one of its foci and revolves around the sun in elliptical orbit here. This is the planet to F1, focus 1, perigee, and this is known as perihelion, and this is known as AE. Then this is F12 aphelion is known as apogee. This is B and this is A. This is aphelion. Then come to second law. Aerial velocity of planet remains constant. Means here the planet revolves around the sun in uniform speed. Means here planets sweeps equal areas in equal interval of time. Here this planet, if the planet is here, it covers equal distance in equal interval of time. This also covers this distance also in equal interval of time. This is known as second law. This dA directly proportional to dt. So dA by dt is equal to L by 2m. L means angular momentum. So angular momentum of the Earth revolves around the sun is constant. So dA by dt is equal to L by 2m. L by 2m is the constant. Next come to third law. Third law states that the square of the time period of a planet directly proportional to cube of a length of semi-major axis. Here, it needs t square time period of the planet square times the cover the length major axis cube time. See here, this major axis, this is known as major axis A t square. See t square directly proportional to a cube. To cover a cube distance, it takes time period twice the time period of the planet. Here t square directly proportional to r cube. Just remember this is very important relation. Next, Newton's universal law of gravitation. Here this is mass 1 and this is mass 2. The distance between mass m1 and m2 is r. The force between these two masses is equal to F is equal to g m1 m2 by r square. Here g m1 m2 by r square. G means universal gravitational constant and m1 is the mass of first object and m2 is the mass of second object. R square, r means the distance between the two masses. Here universal gravitational constant g value is g is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, here the graph would be like here f this is r square. F is inversely proportional to r square, so the graph is like this. Here f is inversely proportional to r square. Next, in terms of vector, f vector is equal to g m1 m2 into r vector by r cube. Remember, this is very important formula. Radius of Earth is equal to 6,400 km. Remember this is very important values which will it will be used in all the problems in the gravitation chapter. Okay, next come to principle of superposition of forces. Here principle of superposition of forces states here this is m1, this is m2, this is m3, this is m4. The whole force acting in this system is here f1 is f is equal to g into m1 m2. Here m1 m2 by r1 2 square. You have to take this distance r1 2 plus g m1 m3 by r1 3 plus g m1 m4 by r1 4 whole square. r1 4 square. Okay. Next, properties of gravitational force is this is attractive in nature. See, this is very important. This is attractive in nature. It is always attractive and independent on the media. See, it does not depend on the any media between the object and the gravitational force and the earth. Here this is earth, and this is object. The between, if we place anything between these two, the gravitational force between this earth and the object doesn't changes. Next, it is conservative force. This force is neither replicated and nor will destroy. Okay. Next, it forms action-reaction pairs. See here, it forms action-reaction pairs. If you throw a ball to the wall, it rebounds. It rebounds. See here. So like that, if you throw a ball vertically upward, it will recomes. It will reappears to same ground due to gravitational force. This is known as action-reaction pair. Action is I am throwing the ball is the action, and reaction is the ball comes back. Next, there is a note point. See here, if this this is sun and these are the planets positions. Here it is planet position at A position and B position at C position. See here, what is the kinetic energy? What is the difference in kinetic energy at different position of the planet? See here, at K, kinetic energy is inversely proportional to distance. So Ka, see, kinetic energy at A position means sun is near, their kinetic energy is more, and at B is less than this but more than Kc. At Kc is less than R2. So Ka greater than Kb greater than Kc. Here motion also speed is here than here. Okay, next come to acceleration due to gravity. Acceleration due to gravity means acceleration produced in the body due to gravitational force. Remember, acceleration produced in the body due to gravitational force. This is known as acceleration due to gravity. Symbol is G. G is equal to Gm by R square. M means mass of the planet. R is radius of the planet. G is universal gravitational constant. In terms of density means G is equal to 4 by 3 pi rho Gr. Remember it. G is equal to 4 by 3 pi rho Gr. This is density of the planet. Then variation of the G. Variation of acceleration due to gravity with height h. See here. If we lift a mass from Earth's surface to height h, then what is the change in gravitational field? See here, gh is the change in gravitational field. This is g, initial gravitation, by 1 plus h by r whole square. This is a formula to find the change in gravitational field for larger heights, means like 6,000 kilometers, 4,000 kilometers, like. See here, h means distance from surface of the earth to object, and r is the radius of the earth. G is the initial gravitation. Then for smaller heights means 4 kilometers, 3 kilometers, like that, gh is equal to g into 1 minus 2h by r. Remember this formula, this is very important formulas. Next, variation of g with depth d. Depth d. If the object knows the depth, then what the g variates? Here, g depth is equal to g into 1 minus d by r. If the object moves go down, the gravitational force increases. See, acceleration due to gravity increases. Gravitational force also increases. Gd is equal to g into 1 minus d by r. This is the formula to find the change in gravitational field. See here, d means depth it traveled. Next, variation of g with the latitude. See here, this latitude. What the g variates? See, g phi is to find the variation of g. We have to use the formula g phi is equal to g minus r omega square cos square alpha phi. G phi is equal to g minus r omega square cos square phi. See here, finding at equator, phi is 0. So cos 0 value 1. So g phi is equal to g minus r omega square. Minimum at equator, acceleration due to gravity is minimum. Remember, at equator, acceleration due to gravity. At equator, acceleration due to gravity is minimum. At poles, here at poles, phi is equal to 90 degree. Object is like this in parallel, so 0 degree. Object is here like this, so 90 degree. So at poles, phi is equal to 90 degree. G phi is equal to cos 90 value 0. So g phi is equal to g. Here maximum. At poles, acceleration due to gravity is maximum. Let's come to note point. At equator, the man felt weightless. Then at equator, the man felt weightless. Then time period is equal to 2 pi root r by g. Then the time period of the planet is time period is equal to 2 pi root of r by g. R is the radius of the earth, g is the acceleration due to gravity. Next, gravitational field. What is gravitational field? The space around the mass which is its influence is felt. See here, this is earth. If your body is here, it feels that attraction, because there is imaginary field lines around the earth which causes the attraction of this object. This is known as gravitational field. What is the formula of gravitational field intensity? See here, E is equal to F by m, force by mass. is equal to gm by r square. M is mass of the object. G is equal to m by r square. E is equal to gm by r square. This is the formula. Then we move on to gravitational field due to solid sphere and hollow sphere. What happens to the gravitational field? Okay, from outside or surface inside. See, smaller means distance between the point P and the center, and capital R means radius. Okay, just first come to solid sphere. For solid sphere, outside the sphere, gravitational field E is equal to gm by r square. Gm by r square E is equal to r means distance between the planet P and the center. Then on the surface, if the point P is on the surface, E is equal to gm by r square. E is equal to gm by r square. If inside the solid sphere, E is equal to gm by r cube into r. Here, gm r by r cube. So here, E is inversely proportional to r square outside, and E is inversely proportional to r square, but inside E is directly proportional to r. Here, according to this graph, this is E, this is r. Here, r less than r, radius of the r is lesser than capital R. Then this, here, r is lesser than capital R means inside. Inside what? E is directly proportional to r. See, graph is like this. And surface, r is equal to r. R is equal to r means surface. Means at surface, E is inversely proportional to r square. Here, graph is like this. Then at outside E small r is greater than r. Means here E is directly inversely proportional to r square. So the graph would be comes down like this. This is the graph. This is very important graph. They will ask in the exams. Okay. Let's come to hollow sphere. Hollow sphere also. Outside the hollow sphere, E is equal to gm by r square. In the surface, E is equal to gm by r square, capital R square. Inside, E is equal to 0. This may be capital R also. Here also, the graph would be like this. Here, inside means r less than r, small r less than capital R. E is equal to 0. So, there is no imaginary. This is the constant. But at the surface here and at the outside, which is inversely proportional to r square, so comes down. For a circular ring, the gravitational field would be here. EP is equal to gmx by r square plus x square whole power 3 by 2. X means the distance between the center of the ring and the point P, and r is the tangent here drawn from distance to the surface of the ring. This is radius. Okay now. Cx EP is equal to gmx by r square plus x square whole power 3 by 2. M is mass of the ring. Then x is equal to r by root 2. Capital R by root 2. Capital R means radius of the ring. For circular disc, EP is equal to 2 gm by r square. The same diagram before what? 2 gm by r square into 1 minus x by root r square plus x square. Root r square plus x square. For concentric spherical shell means shell inside the shell. Here, this is M1, shell mass M1, shell 1 mass, then this is shell 2 mass M2. Here, distance, this is A point, this is B point, that is C point. This is R1 distance from center to the point B and R distance from center to the C. At C, what is gravitational field? EC is equal to gm1 by r square plus gm2 by r square. Say gm1 by r square plus r square. This r, we should consider this r. Okay now. Then g by r square into m1 plus m2. For at B, we doesn't consider this cell. Okay. EB is equal to gm1, this m1 by r1 square. R1, what is the distance? Okay. Then at A, there is no gravitational field. Remember, there is no gravitational field. Means shell means hollow sphere. Hollow sphere, inside the hollow sphere, the gravitational field is 0. Like that only. Concentric spherical shell means this is 0. Point A is 0. Let's come to null point. What is null point? Null point means the gravitational field where the gravitational field is 0. Here, the gravitational field where is the 0, that is known as null point. Here, this is M1, this is M2. The gravitational force between this is like this, and this is like this. Where it is null between the gravitational field between these two masses. Here, this is a null point. E is equal to 0. And what is the formula to find it? Here. But even here, It should be 0 means E1 is equal to E2. See here, E1 is equal to E2. Must be E1 is equal to E2. Then E1 is what? Gm1 by x square x here. X, distance between this is x square is equal to Gm2. Gm2 by r minus x square. This is r minus x. See, this is r, so this is r minus x square. So, null point is at x distance from m1. Here, null point is x distance. At x distance from m1. From m1 to e0, this is x distance. And r minus x distance from m2. The null point is at r minus x distance from m2. Here m2. So you have to find what. Then if they ask the question from where, you have to choose it. Okay. If they ask from here also, if they ask from here also, you have to solve the problem. Next come to gravitational potential. What is gravitational potential? The amount of work done to bring a unit mass to from infinity to field. Here, this is Earth. Okay. This is gravitational field, but mass is at infinity, you have to bring the amount of work done. What is the work done to bring the unit mass from infinity to the field is known as gravitational potential. Here V is equal to minus Gm by R. Minus is due to opposite to the gravitational field, so minus Gm by R. See here. Next come to solid sphere and hollow sphere. Gravitational potential due to solid sphere and hollow sphere. See, R is the distance between center, small r, and P, capital R is the radius. Okay. Solid sphere. Outside the solid sphere, V is equal to minus Gm by R. And the surface, V is equal to minus Gm by capital R. Inside, V is equal to minus Gm by 2R cube into 3R square minus R square. It is very important. Then due to hollow sphere, outside V is equal to minus Gm by R. Surface V is equal to minus Gm by R. Inside V is equal to minus Gm by R. There is no change in the gravitational potential. Okay. What is the relation between the gravitational field and the potential energy? See here. Potential, gravitational potential and gravitational field. E is equal to minus dV by R. E is equal to minus dV by R. It is electric field is negative gradient of dV by dr. Okay, potential, negative gradient of potential. E is equal to minus dvx by dx plus dvy by dy plus dvz by dz. In integration form, V is equal to minus integration of ex dx plus ey dy plus ez dz. This is very important formula, remember it. Gravitational potential energy. What is gravitational potential energy? U is equal to minus Gm1 M2 by R. Minus is due to opposite to the gravitational field, minus Gm1 M2 by R. Mass is M1, mass of M1, and M2 is mass of the second object. Here, application 1. Okay, this is mass 1, this is mass 2, this is mass 3. The potential, what is the gravitational potential energy of the system? U is equal to minus of Gm1 M2 by R12 plus Gm2 M3 by R23 plus Gm1 M3 by R13. So do like this, we will get the potential energy of this whole system. Next come to what is escape velocity. Escape velocity means velocity required for object to escape from the Earth's gravitational field. Velocity. How much velocity is required for object to escape from the Earth's gravitational field? This is called escape velocity. V is equal to root of 2 Gm by R is equal to root 2 Gr. Okay, this is G is gravitational constant and N is mass, and this is gravitational acceleration due to gravity. This is radius of the Earth. At height h means V escape velocity is equal to root 2 Gm by R plus h is equal to root of 2G into R plus h. In case here we have to add height. Okay. Escape velocity of Earth is equal to 11.2 km per second. On solving, we will get escape velocity of Earth is equal to 11.2 km per second. Next come to orbital velocity. What is orbital velocity? Velocity required for object to revolve in orbit. Here, velocity required for object to revolve in orbit. There is a orbit around the Earth. If the object have to revolve the orbit, then it should, like the satellite, then it should need this velocity, orbital velocity, to revolve. This is known as V0. Vo is equal to root of Gm by R is equal to root of Gr. At height h means V0 is equal to root of 2 Gm by root of Gm by R plus h is equal to root of G into R plus h. Vo is equal to 7.9 km per second. Orbital velocity of Earth is equal to 7.9 km per second. Then time period of satellite. How to find time period of satellite? P square directly proportional to R cube. This is the relation is very important. They may ask in the NEET exams. Time period of satellite is P square directly proportional to R cube. Next, orbital angular momentum. Orbital angular momentum L is equal to m into root of gmr. M into root of gmr. Next, come to note. If velocity less than orbital velocity, then body returns to ground. Return to ground. The body does not travel around away. It returns to ground. Okay. If velocity of the body is equal to orbital velocity, then body revolves in a circular orbit around the Earth. Around the Earth it revolves. If the velocity is greater than orbital velocity and less than escape velocity, then body revolves in elliptical orbital. Means elliptical orbital. It revolves in elliptical orbital. Then if velocity of the body is equal to escape velocity, if the body has a velocity equal to escape velocity, it escapes from Earth in parabolic path. It escapes from the Earth in parabolic path. Like this, it will escape. Then if velocity greater than escape velocity, then body escape from Earth in hyperbolic path, like this hyperbolic path. It escape from Earth in hyperbolic path. Next come to energy of the orbiting satellites here. Energy of the orbiting satellite means what is potential energy? Potential energy is equal to minus gm1 by r, and kinetic energy gmn by 2r, and total energy is equal to kinetic energy plus potential energy. So E is equal to minus gmn by 2r. Total energy is equal to potential energy plus kinetic energy. So minus gmn by 2r. See how would the graph would be like? See here. This is r. Then here kinetic energy is positive, so in the positive axis given by 2r, inversely proportional to r, so like this graph. And for here total energy is here like this, it is negative, so in the negative axis, so E, then potential energy is negative, but it is inversely proportional to only r, so it's sort of upper like this. Then what is geostationary satellite? This graph is very important, so remember it. Geostationary satellite. What is geostationary satellite? If time period of Earth is 24 hours, that satellite is called geostationary satellite. If in problems, if they said that if the geostationary satellite like questions, you have to use time period. T is equal to, they would doesn't give the time period of that in the question. You have to remember it. Time period is equal to 24 for geostationary satellite. Remember it. Okay. Next. So okay, I hope that what I taught today you have understood it. So thank you friends. Don't subscribe to like and subscribe. If you want my short notes, please subscribe and just follow and message me on Instagram at filmistar789 or Facebook Rohit. We will help you there. Don't forget to subscribe guys.